Well, hello again, advanced algebra students. We're ready for our video here for our Friday. So this is going to be on translating the sine and cosine function. So we've translated functions before, and we're just going to learn how to do it now with the sine and the cosine function. So basically this means moving it left, right, up, down, stretching or shrinking the function is pretty much what it means. So let's go ahead, let's take a look at some basics here. First, some reminders. Vertical shifts are when we take our function and we add k to it, that moves it up. Or if we subtract some number k from it, it moves it down. So that's our up and down. We've had this before. If we want to move it horizontally, so for horizontal shifts, we will add h to it. Now remember, horizontal shifts are counterintuitive. So if we add h to it, it actually moves it left h units. If we subtract h, it actually moves it to the right. So it's important to remember that horizontal are counterintuitive. Okay, so now let's look at our basic equations for sine and cosine functions. So our basic equations look like this. Here's our basic equation for the sine function. So it's a times the sine of b times x minus h plus k. Okay, now normally we're not going to be doing all of these things like multiplying by an a b, and subtracting by an h and a k all at the same time. But we could be. Most of the time we won't give you those. We'll give you ones where we're doing up to two things at a time. And there's our basic equation for the cosine function. So notice a vertically stretches or shrinks, b horizontally stretches or shrinks, h shifts left or right, and k shifts up or down. And the way that we've done this, notice I've written it as h minus k, so or x minus h, which will make that a shift h to the left or to the right. So some important terms that we have, the absolute value of a we call the amplitude. We've talked about that before. That's how much vertical stretch or shrink there is. So that's our vertical stretch or shrink. 2 pi over b, you should already recognize 2 pi over b. 2 pi over b is the period. So whatever that b is, the 2 pi over b would be the period. The h, we name that the phase shift. It's actually the horizontal movement. So if we talk about phase shift, we're talking about horizontal translation or horizontal shift. And finally, k we call the vertical shift, or we call it the vertical translation, the vertical movement up or down. All right, let's look at some examples of how we're going to do this and what we're going to do with these. So like I said, this is similar to what you've done before. It's just doing it now with trig functions. So number 11, if we look at number 11, it tells us that we have the cosine of x minus this 5 pi over 7. And it asks us to want, in each example here, it asks us to determine the h, which is the horizontal shift or the phase shift, and then describe each. So in other words, describe it in the language of translation. So first my h, since my h here is what is subtracted from x, so this is 5 pi over 7 is subtracted from x. So that is our phase shift, would be our 5 pi over 7, and we would describe it as it's a shift. Since it's subtracted, it's going to go to the right, shift to the right, 5 pi over 7. That's all we have to say, just like we've done before. Shift to the right, 5 pi over 7. Now let's look at 13. 13, it gives us a picture. So you do have to look in your books on page 880, and you'll see a picture. It's kind of a stair-steppy looking function. It's not exactly a trig function. But what they want us to do is they call that function f of x. And they want us to graph the translation for the function g of x, where I've taken that function f of x and I've subtracted 3. Well, subtracting 3 moves the whole function down 3. So what you want to do is you want to pick points that you can see on the graph and then move them down 3. So notice one of the points that I see on the graph on the y-axis, it is at 2. So it's at 0, 2. So I'm going to take that point and I'm going to move that one down. So I'm going to take the y-axis point that was here at 0, 2, and I'm going to move it down, and so it's going to become at -1. So each point or each corner of this graph, I'm simply going to move down 3 units. So I take this one and move it down 3. There was one right here, take it here, move it down 3. So each point that I see, each point on the existing graph, I'm simply moving down 3 units. And so it produces the exact same looking graph, it's just been moved down 3. So I think you guys can do that fairly easily, and you'll see it when you look at there in your book. All right, let's look at 21. So 21 gives us the following equation. It gives us y equals the cosine of x plus pi. So this, oh, sorry, I was looking at the wrong one. Cosine of x minus pi. So this pi is inside the function. It's subtracted from the x. And it asks us to graph the translation on the interval from 0 to 2 pi. So here's the way you want to do this. You start with your basic cosine function, and notice what this is doing is it is just moving it right pi. So I know the cosine function starts at 0, 1. So what I do is this dotted line is my basic cosine function, and all I'm doing it is I'm moving it right pi. So I start here where it started at 0, 1, and I just move that point to right there. And then I know what it does from there is it goes down, crosses, and finishes there at pi. So I'm just going to go down. This goes down to 3 pi over 2 and finishes at 2 pi. So that's the end of it. Now I just have to go and put in the part that comes before. So I just simply translate in the part that comes before and gives me 1 full cycle. So it's just been pushed to the right pi. That's all I've done. Done a sketch, pushed it to the right pi. All right, next one, 23, wants us to describe any phase shift and vertical shift. So this is pretty simple here. So the 4, notice first, is not shifting it at all. That's a vertical stretch. 23 does not want us to describe the vertical stretch, just vertical and horizontal shift. So notice the horizontal, I'm adding 1, so that's going to move it left 1. And then I'm subtracting 2, which is going to move it down 2. So I would simply say shift left 1 and down 2. Just like we did before with transformations, only now it's a trig function. Finally, 27, most complicated kind you're going to have. In this one, it wants us to graph this in the interval 0 to 2 pi. So notice we have the sine function, and notice what these things do. It moves it left pi over 3 and up 1. So it's actually easiest to handle the up 1 first. What the up 1's going to do is it's going to take that midline and move it up 1. So what I would do is I would go, and instead of it being centered on the x-axis, I'm just going to move that up 1, and I know it's now going to be centered 1 higher. And I know what the sine function does is it starts here at 0, 0, and it goes up and down. So this is just going to go up 1 unit, and it's going to go start there, but it's also going to go to the left pi over 3. So I just have to go up 1 and go to the left pi over 3, and now I start there, and I just match my sine function. It starts there, it goes up 1, goes back down, dips down 1, and then it just keeps following this pattern here. And that becomes my sine function. I would suggest verifying that with your calculators to make sure that you've graphed it correctly. Okay, that's it. Transforming, sketching, and identifying these pieces of these trig functions is what you've got. So it's going to be 13.7. It's going to be numbers 8 through 14, and then 18 through 28, just doing the even ones on those. Okay? So you don't have to do those odd ones there, and you don't have to do the one, you can skip number 16. Number 16 is one you don't have to do. Okay, so go ahead and have at those, and we'll look forward to seeing you next week.